What is going on, guys? It's Dashdrop here again, and this is the second part of creating a chess game in C++. So, I just fixed a couple of things. I realized that we had black chess pieces for both sides, which obviously is incorrect. And I also touched up the pieces a little bit, so they look a little bit cleaner. Not perfect, of course. The knight kinda looks like a dog, but that's okay. So now we have a white side and a black side. As I discussed in the previous video, I was going to basically add every move that a chess piece can make across the board. So I've actually set that up just a little bit. I broke out the main functionality of the chess pieces and the tiles into a texture object, because that's basically what it is. It's just a texture with a rectangle and some coordinates. And then maybe I want to do more things to the chess pieces and the tiles separately, but just so we can separate what kind of object it is. So then I can also change this to tile, because these are tiles and not chess pieces. And then maybe I'll just create a tile object here, and I'll be using this instead of the piece, just to make it a little bit clearer. It's not that much extra code, so I think it's fine. Now let's keep these guys together. So yeah. So let's make sure everything works. It does not. And that's okay, because this has to be a texture object instead. And let's just rename this to texture object. There we go. So now we're passing a texture object, and we also have to change the actual declaration here to texture object. Yeah, we don't need that load texture because that's an old function. And let me just go ahead and split these up. I can make it a bit clearer. We've got our getters here and our setters here. Okay, so that's great. And there are no more setters or getters here. That's perfect. And then we can just do render functions, because these are all related to actually rendering or clearing the renderer. Now it should work, because we changed that to texture object instead of the chess piece. Okay. I mean, something's wrong. What did I do? Okay, I think I know what's going on. Right here I'm offsetting the chess pieces, but I'm never offsetting the actual tiles. So what I have to do is set tile.x width times entity size, and then the same with the y. Maybe that was the issue? Yeah, there we go. I would also like to move this out to the actual constants file, so the board size. There we go. I'll place it right here as well. Now I think I can remove the print board because we're already rendering it out, so that won't be necessary. Now we can actually get started on creating the moves. So what I'm thinking of doing is having a vector with a bunch of cues, and the cues are basically gonna be every single path they can go. So for the chess pieces, I want to have a vector of cues, and then the cues are just gonna be coordinates. So the cues are actually gonna have, maybe I wanna put pairs. Let's do a pair of two integers. That's just gonna be the x and y coordinate. And then I want to name this moves. And I am forgetting the last arrow there. So let's just draw a little bit to make this a bit clearer for myself especially. So let's say we have our beautiful chessboard here, and we have a pawn right here. So the first move that the pawn can make is right there. So those two tiles. So the pawn is going to be at 64, 64. Then the next step is going to be 64, 128 and 64, 172. And then so forth for all the other pieces. So what I can do, let's start with the pawn. We want to do what? So this is the top row of the black pawns. Let's actually do add move. So let's create a function, because I put this in private. Let's do void add move, and then this is gonna be a pair. So this is what I'm thinking, right? We have the queue of every single pair. So this is gonna be the coordinates. And then we have a sequence. So the entire queue of the pairs is the move sequence. And then the vector is every single move sequence, since some pieces can move here and they can move there and so forth. So I think that works for now. I might actually update it later because it might get messy. I'm not sure yet, but we're gonna stick with this for now. We can also make some new types for these to make it clearer. So let's just do using coordinate type is the pair, or let's just do coordinate for now. And then we can do, there we go. So we have the coordinates, which is the pair, and then we have the move sequence, which is a queue of all the coordinates. And now we can just go ahead and replace this with coordinate, because we're going to add a new coordinate and then create a move sequence from that. And then we can obviously just replace this with the move sequence too. Okay, beautiful, beautiful. So we have the add move function. Let's do add move, and then the coordinates. Let's do piece.x and then piece.y plus the entity size. And then I'm gonna have to wrap this in braces like that. So we have the same x coordinate, but we have one step down, and then I'm gonna have to add the other one. So this is gonna be entity size times 2. So there we go. I would also like to render this out somehow. I think I want to make a new function called render moves. And now that I'm thinking of it, I want to put these in private because I don't want everything else to be able to access the functions. We got the render moves, and then I'm somehow gonna have to iterate over all of the boards again. And I'm gonna make a render rect function. Actually, I think I already have a render rect, don't I? Let's see, render rect, yeah. Perfect, perfect. And this is probably gonna get messy, but that's fine, that's fine. We don't need the board, we only need the pieces. So let's do... There we go, so we're referencing the piece at this position, and then we're gonna have to create a rectangle. Move rect, and then we're gonna have the, let's just make a get moves function too, so we can actually get the vector. Get moves, gonna be a vector of move sequence. Get moves, we can make this constant because we're only gonna actually get the moves, we're not gonna mess with them. We can return the moves, and I think I can also make this a constant reference like that. So let's do there we go. So we are getting the moves. Perfect. We have every single move. So we're gonna have to iterate over the moves. Auto move in moves. We're gonna create a rectangle for every single move. So move.front, that's the coordinate. Now if we access the first, we have the X position, and then the second is going to be the Y. So let's start by doing that, and maybe I can call render moves just like that, and I just want to put a debugger there to make sure that it's the correct values. So we have the moves, so the first move has 1 unit, and that's 0 and 64. Is that really what we want? Maybe I have messed it up somehow, because this should be for the pawn, but it doesn't seem like it's for the pawn. I think in order to make this clearer for myself, I am going to add a name. So I'm just going to do sg string name, and I can actually make this public because I only want to use this for debugging. So when we create a new piece, and I want to set the piece name. Hello. Oh, it's because I'm not including string maybe? Yeah, there we go. So we want to set the name to rook. Let's just do black. There we go. Now we'll set the names for each piece. And now when we run the debugger, we should be able to see the actual name of the chess piece. So let's see. We have a piece. So that's the pawn black. Okay, so we are looking at the correct item because the only piece that actually has moves is the pawn. That's right. Okay, so the first is 0 and the second is 64. But it should be 64, 128. Oh, right, because we're actually setting the... Yeah, we're actually offsetting after adding the pieces. That's why. So let's just do this up here before we actually add the piece. Then we can add the piece right there. Okay, that should be fine. So now if we look at the moves, the first one is 0, 128. That's exactly what we want. And the second one is 0, 192. So apparently I need to retake my math courses because this is 192, not 72, because 60 plus 20 is obviously not 60. So I apologize for that. Anyway, we have the coordinates. That's wonderful. And now we have to create a new rectangle. Move rect. And then we're gonna set this to this, and it's just gonna be the entity size. Like that. And maybe to make this clearer, I can make these consts and just do const int move x and then move y. Here we go. And then move x, move y. We have a rectangle and now we just have to render it out. And I guess this needs to be dereferenced. So I think the last step is to actually fill the rectangle with something. Just set the render draw color. So let's get the renderer. And then we want to pass in, let's just do white for now. And then we just have to build the rect. So we gotta get the window get renderer and then the move rect. And now that we render it out, we should have 2 white tiles right below the pawn. Yes, we do. So the steps are generated for each of the pawns. That's great. What we can actually try to do is to draw rect instead, because I think that gives us a border instead of a full color. Yeah, there we go. So there are the moves. Now, what I want to do is maybe I should add the actual vector as a parameter. I'll just make that constant since we're not changing them. Name that move sequence or just moves because this is the actual move sequence. And we can remove that because we're still using the moves. Let's add that right there too. So basically what I want to do is, so when we click on a specific piece, it should render only those moves. I'm gonna have to add some kind of event here. We're gonna see if the type is SDL mouse button down. So check if a chess piece has been clicked. So if the mouse button is down, it means that we have actually clicked the left mouse button. And now we have to basically loop over every single chess piece again. Now I actually don't need this either, since we're only rendering the actual moves for the specific piece. So that's great. But I think we will have to add a for loop in this and then get the piece. And maybe I should make a check. So let's add a little bool. Let's mouse over, initialize to false. Or maybe we should make a function instead actually. Let's just do let's mouse over. We're gonna wanna have an X and a Y. And we just return if the X is greater than... Does that work? Because the rectangle is inherited, so that should work. So let's check if the X is less than the X plus width. I guess this is pretty basic collision checking. And then check if the y.h. So this is just checking if the x and the y coordinates are within the actual chess piece area, so to speak. Okay, what we need to do now is check if the piece, let's do event dot motion maybe, x and motion dot y. So what does this say? The type color is not compatible with the is. Oh, is it because this is constant? What if I just make the function constant? Yeah, there we go. So for starters, I'm just gonna print out, and then we can actually print piece.name has been clicked. Let's just comment out render moves so we don't get an error when we build. Okay, let's see. We're not getting any prints. A bit odd in it. Okay, so the mouse is clicked. That's great. Ah, of course. I'm obviously comparing the same x's. I have to actually call this .x and this .y. That's gonna call these guys instead of passing in these again. So maybe this works now. I'm not sure. Yeah, pawn black has been clicked, bishop has been clicked, king has been clicked. That seems to be working just fine. That's great. Now all we have to do is render out the actual moves. So if we render moves, we can do piece.getMoves, and this should render out the moves right under this piece. It doesn't, because I'm rendering this before, I mean after, so it's gonna be layered under. So maybe what I can do is just, this is probably gonna be really ugly, but that's fine. There's the vector, move sequence, moves to render, like that. I can just do moves to render. Okay, let's just do that. Piece, get moves, and then we can render moves, moves to render. Okay, there you go. Simple as that. So now we got the moves, and then when we click one of the tiles, the piece should move there. So these guys obviously don't have any moves yet. That's okay. And then I have to add some moves for these guys too. I can just do that real quick up here. This is for the pawns. So what I'm gonna do is do the exact same thing, but this should be minus, because we're gonna be moving up. There we go. Okay, looks pretty nice, pretty nice. Maybe we should make the actual move function now. So we want to do the same thing, but for the moves. They should also be in the mouse button down event. Maybe I should actually save this piece as a chess piece reference. So that doesn't work. Let's just do it like this. We can do piece to move, piece. We'll make a new function here. Mouse over move. Make this constant. And I want to return. Maybe I'll just make a move sequence or just a coordinate. Plus, we're just gonna do empty size. That should work, I hope. I'm thinking of removing the Q and replacing this with a vector instead, because it just seems problematic when I try to iterate over the move sequences. So auto it is move.begin. So we're iterating over every sequence, and then we're checking if mouse over move. We can pass in the iterator as coordinate, I think, and then the event motion X, event motion Y. I guess what I can do is just get a... Guess I can do that, and then just pass in the coordinate. Still doesn't seem to be working. Okay, I just had to declare it as const. That was the problem all along. Let's pass this in as a constant parameter. Okay, so if we are over the move, then we want to we can create a move function for that, and then set new x and new y, and then we can just set x equal to new x and y is the new y. And then we can move this to coordinate first and coordinate second. Maybe this works, maybe this doesn't work, I have no idea, but we will see. So we got the moves, and doesn't seem to work. Okay, just for fun, I'm going to get the key states like that, and then I'm gonna try to move the chess pieces manually to see if it actually moves around. If the key states is SDL scan code S, then we want to do piece to move y minus equal 2. Let's just do that and see if it actually moves around. I'm not getting any movement, and I actually know exactly why. It's because this object is just it's just copying the piece, so it's updating, but it's not the piece on the actual board. So that's why. That makes more sense. Okay, so clearly I have to retake the C++ courses too, because I can obviously just do a pointer. I mean, come on. So what I can now do is clip out all of this. I can do piece to move is the piece, and we're gonna have to deref that guy. And now what I want to do is check if piece to move is not null. We want to do piece to move, get moves, then piece to move, move, piece to move, name, and piece to move y. If I'm not mistaken, this should fix all of my problems. Now I can also just cut that out and put that right there. Actually, I'm not setting this to anything, so instead what I can do is simplify this even more by removing that, because we have a pointer to the piece, so we can just do piece to move, get moves. There we go. Let's see if we fixed it. Now we click, and he is moving, but we're not rendering out the moves, because we're not actually calling the freaking render function. So the piece is clicked, we can just render moves, piece to move, get moves. There we go. So we are still having problems moving the piece, but we are making some progress. So what's going on here? What if I just add an enum, and let's do move state, and then I want to write waiting for move, waiting for piece. If we're waiting to make a move, or we're waiting for the piece to actually be selected. So let's see. We also need to make a state. Move state, state. If state is equal to move state waiting for piece, then we're gonna do all of this. And then else if state waiting for move. There we go. And I suppose we can initialize this to move state waiting for piece, because that's the initial state of the game. Let's check if that works. Still doesn't work. Of course, we're not actually resetting the state here. Now we're waiting for move. There we go. There we go. We clicked a move. Perfect. Now we are up and running. So if I now do piece to move dot move, I set this to coordinate first and coordinate second, the piece should move to wherever we click. Yes, but there is a rendering issue. Okay, so I'm just adding some key movements here to see we can actually move this around. Oh, so it's something with the tiles. Maybe I have to do this just to separate them, so we render the entire board first and then the pieces. That might be the problem. Yes, there we go. We finally got it to work. So it's just this motherfucker right here we need to split out. So now we can remove the key movement. So now we have a game where we can actually move the pieces. The only thing I need to do is be able to reset all of this after the piece has been moved. So this has been moved. Now we have to set the state to waiting for piece because we've already moved it. And maybe I could add a check to see if the state is equal to waiting for move. So when I move, this should no longer render, and it's moved. Perfect. And I could also set piece to move to null pointer. And then I guess that doesn't really matter, but I'll keep it just for extra security. So now that I move that, I can move the other pieces, and it's still a little glitched. But that's all good. At least what we can do is negate this expression to remove some of the nestling right here. That goes away, and then we can just do break, I believe. Let's print where the piece ends up. So we move it to 64, 192. So now that I have moved this, I think it's because I'm not updating the moves for the actual chess piece. So in the move function, could also do, this is the vector of the coordinates. So now we have the first and the second. The first, guess what we could do is create a const int diff x minus new x, and then diff y is y minus new y. Might be overcomplicating this as hell. That's okay. Now we're gonna add the diff to the moves. I don't know if this is gonna work or not. Nope, still the same. Maybe the problem is that I keep iterating. Maybe if I break here. No. The piece has been found, so maybe we have to break there too. Okay. I mean, that's progress. We just have to update the moves correctly. Maybe I don't need this break. Right, exactly. Okay. Piece found, break, iteration. Now, when I actually move the piece, I want to make sure that these are updated correctly. What if I were to do the opposite? I'm just testing. Okay, that's great. So we've got a really messy function here, but at least it kind of works. So that's great. We are now able to move the pieces. The pieces look a little bit better. So I would say that we have made some good progress for the chess game. And obviously I'm gonna have to add some collision later to check so the pieces can't move into each other. So that would be ridiculous. But we have come pretty close to making a chess game in a little under 4 hours. So that's great. That's great. 90% debugging. Welcome to programming. Anyway, that's gonna do it for this part. And in the next part, I'm going to add the collision and try to fix the moves for the other chess pieces as well. So I hope you enjoyed. So please like and subscribe if you did, and I will see you later.